All right, hello everyone. We are on night 4 of databases. So in the spirit of night 4, we're going to take a lot of what we've seen the last 3 lectures and tie them together and tie it all in with a little bit of theory. So one thing I want to say out of the gate, so you guys don't feel like you're going insane, is there is no guided project on Training Kit. So what we will be doing for the guided project today is starting from scratch together. So you will find no guided repo on Training Kit. If you're looking for one, it's not there. If you somehow find one for tonight, it's probably because you've somehow dipped into another dimension, and that's strange. Anyways, so what we're going to be talking about, another thing I want to say about tonight is that there is a lot of, we're talking really about designing databases. We really want to, tonight isn't just about the mechanics of how to do something. It's very much about how to think about these databases. And in the spirit of that, there's a lot of nifty theory stuff on Training Kit. I'm going to talk a little bit about it, but I want us to take more of a hands-on approach. So if you do want to get deeper into the theory, you're welcome to look through Training Kit. I think Luis gets more into it in his lecture. I bet you can also find other online resources. So feel free to go that route if you're so inclined, but most of what we do tonight will be more digging into the weeds of this database stuff. So on that note, let me share my screen and we will get right to it. All right. Okay, so we're going to start off tonight with a little exercise. So up here, I have this screenshot of a database. We see it has 4 fields and some cool data inside of it. So we're going to play a game called What's Wrong with This Data, or What's Wrong with This Table? So I'm opening up the floor to you guys on Slack. What is wrong with this table? Awesome. You immediately clued on the first problem, which is there's no ID. Now, it's entirely possible that this name field could be our primary key, but we really like the ID field. We really like having an ID. So that's absolutely right. All right, what else? All right, so duplicate info, multiple concerns, both good answers, kind of thinking about the same thing in slightly different ways. So the multiple concerns, it can be a little tricky to figure out where to draw the line, because it's like over here we have the name of an animal, over here we have the address of a zoo. Technically, yes, this is the address that Snuffles resides at, but by the time we get over to address from name, we're pretty far removed in how the info is actually connected to each other. So that's what I would think of as this multiple concerns issue. It's that these columns, while tangentially related, aren't as closely related as we would maybe like. The more concrete thing that we can see here is that there's duplicate info. We see that over here in species, there's a couple versions of the same thing, but over here in zoo and address, it gets pretty extreme where there's a bunch of different copies of the same info. So if you aren't convinced that this is a problem, just take a moment to think about what would it be like if the San Diego Zoo moved. Well, that would be actually far more difficult than the concern of changing the database would be moving the animals. Let's say something slightly simple. The San Diego Zoo is renamed. Maybe, products, some corporation bought it. Now it's the Google Zoo, or something like that. So all in the zoo, as far as the zoo is concerned, they have to change some signs, but how much of a pain in the butt would that be for us as a database developer to have to go in and, yeah, we could think of a query to catch all, but that's kind of ugly business. That's really ugly business to have to go in and presumably we only have 7 entries in here, but there are a lot of animals in the San Diego Zoo. So that's one of many reasons why that duplicate info isn't nice. Just like in the actual code bases, we don't like having copies of things because when you want to change something, there's lots of opportunities for things to go wrong. So here's another challenge for you guys. I'm actually going to give you guys a couple minutes to work on this. I'd like you to list assuming that we don't like this table, that probably means we need at least 2 tables. We need more than just this one table to capture the same information. So can you guys come up with which tables you would use to capture the same information, but in a more meaningful way that wouldn't deal with this whole repeat issue and that maybe would involve some foreign keys? So I'm going to give you guys, let's say, 3 minutes to think about what tables you would use to capture the zoo animal information. So. And I'll have you guys share what you come up with when we're done, but I would ask you to wait until the 3 minutes is up so that other people can keep thinking about it. So I want you guys to think about designing a schema that would contain all this data. So what tables and what columns in those tables? So right now, let's say there's just this one zoo animal table that contains all this stuff. To deal with some of the issues we just talked about of separation of concerns, repeated data, missing IDs, what tables would you design to contain this information, but in a better, more clean, usable way? Oops, I muted myself, sorry. Okay, so let me hear what tables you guys came up with. What tables would you want to use to capture this data? Cool. So it looks like a lot of you guys separated it into animals and zoos. Not a bad way to go. Here's one thing I do want to point out though, which is notice that we also have repeats in the species category. So it might be even better to separate it into animals, species, and zoos. And if we wanted to, we could even push it further and separate out address into its own table, which I'll, in a little bit when we talk about one-to-one relationships, I'll talk about what scenarios you might want to do that. But I think that separating zoos and animals would be the absolute first step. But I think what would be even better to avoid this duplicate info issue would be to separate out animals, species, zoos all into their own tables. So let's talk about, and we will actually dig into this a little later tonight. But before we get into that, I want to step back and talk about some theory and talk about, in general, what we like to think about when we're designing databases. So I'm going to pop on over. Well, first of all, I want to repeat some of the things that have already come up tonight, which is we always want primary keys. That's the most important aspect. And it's really just really good practice to just make those actual IDs, like integers that increment. We really don't want duplicates. There might occasionally be a situation where that comes up. For example, if there were duplicate names, that might be fine because maybe there's an animal called Gwendolyn in the St. Louis Zoo and a totally different animal called Gwendolyn in a San Diego Zoo. That's perfectly fine because that's not a true duplicate. Those really are separate entries that just happen to have the same name. Like if we had a directory and there were multiple John Smiths in it, that would be fine if they all represented different people who just happen to have the same name. Where we get in trouble is when chameleon here and chameleon here, they refer to the same species. The San Diego Zoo, San Diego, those refer to the same literal zoo. So every entry in a database that matches something that exists in the real world, there should be a pairing between that. There shouldn't be multiple copies of the same thing in our database. The other issue that came up was this idea of, how did someone phrase this? Multiple concerns. That was a really good way to phrase this. It's that, and this table isn't a horrible example of it, but if you had some sort of, let's say we were working with kind of this online ordering database in that example that we've played with online. If there were a table that both include, like the home address of the employee who processed the order, along with the home address of the, a customer, those things really only are very, very tangentially related. So we want to make sure that everything that's in a table together really conceptually relates to each other. So let's talk about something called data normalization. And as I sort of mentioned at the beginning, there's a lot of theory in Training Kit. I'm going to brush over some of it, but mostly I want us to get our hands dirty tonight. So this is here if you want to read it and go deeper, but we're just going to touch on it tonight in this lecture. So I really like this definition of normalization, which is maximum consistency and minimum redundancy. That's kind of a fancier, sleeker way of saying what we've already said. Redundancy means we don't have repeats. We don't have multiple copies of things. Consistency means that things actually make sense, that the concepts we're trying to capture are captured in the actual structure. Another good way to think about this normalization process is that we get rid of these anomalies. And I'll let you guys spend time really thinking about these on your own if you want to. But a couple examples are, I really like this. So we cannot create a new class record because the record requires at least one student. That shouldn't happen. The class, even though hopefully the class will have students eventually, we should be able to create a class without it containing students. If there were a table that had a class field and then it had a required student field, this issue might occur. And it really just touches into this idea of usability. If you're trying to use your database, if you're trying to do something meaningful and correct and your database schema is interfering, something has gone wrong in the design. There's some other anomalies that they mention here that are kind of the similar thing. We actually somewhat experienced a delete anomaly a couple weeks ago when we were trying to delete something and it wouldn't let us. So when you have designed a normalized table, and we can really just think of normalized as meaning something that's designed to be functional and usable and meaningful and create an easy experience for our database team and the backend developers. Now, if you want to really get into the weeds of this theory stuff, feel free to play with this normalized form business down here. I'm not really going to talk about it because honestly, I think that until you've really played with this, until you've seen the rest of the lecture and done the homework, this stuff probably will seem mostly like gibberish. So, but I would, after you've finished the project for tonight, if you're curious and you want to go deeper, I would encourage you to come back and think more about these anomalies and read through this normalized form, the first, second, and third normalized form stuff. Okay. So that's what we've got. And I know this theory stuff can be tough to make sense of before you've really seen many examples, which is why we're going to spend the most of the rest of the night actually building databases and designing schemas and working with them. Does anyone have any questions about the theory of database design so far? And one other thing that's worth mentioning here is, generally speaking, as a developer, you won't have to be designing a schema. There should be a database, someone who's a database expert who does that. However, it's good to understand this. You will have to be designing database for your own projects and labs. And the more you understand, the better you can communicate with the database folks. Plus, you never know. Sometimes you'll be on a smaller project and you will have to do the schema design. So you'll save yourself so much time and so much energy and so much grief if you start out with a really well-designed database. Okay. So I'm going to bust out this whiteboard, which is kind of wonderful and kind of horrible. And let's see if we can come up with a schema. So notice that I'm not jumping into Connects. I'm not jumping into writing code. When we're designing anything, whether it's a schema or the layout of our API, it is really worthwhile to sit down with a pen and paper or whatever electronic tool you want and think about it first, or an actual whiteboard. Just spending a little bit of time thinking about what you want your code base or your database to look like before you start jumping into the code can save you a lot of time later. So let's talk about the different databases we might want to have here. Let's scrunch that over. Or sorry, the different tables. My drawing skills are a little questionable. All right, so the first thing we know we want is some sort of animals table. And this represents the literal animals. It's not type of animals, it's the literal animals that we have in each of our zoos. We, of course, know that we want this to have an ID. And we also want it to have a name. I apologize for the handwriting. And then I'm going to leave it there for now. We're going to have to link up these tables at some point, but let's just leave it there for now. The next thing I would like in my database is, as I said, I'm going to keep species separate because it's, you know, we saw that there were already some repeats appearing here. So this will be our species table. And of course, this will also have an ID. And we also need a name field referring to the name of the species. So far, so good. So I am going to split zoos and addresses into two different tables. And I will do this with a caveat. which is that honestly, in this example, if I were really just building this for the sake of building it, I probably would include them together in one table. But I will split them in this case just because I want to give you an example of something called a one-to-one relationship. And in just a minute, I'll explain to you what that is and why you might want to do it, even if maybe in this case, it seems a little clunky and like it's creating more work for us. But it's all right to create some more work if it's for the sake of learning. All right, so this is going to be zoos. Quite like the other field or the other tables, we see that this has its own primary key, and it will also have a name. And then finally, we have address. Now, if we wanted to get really sophisticated with this, it might be worth separating this into street address, city, state, zip code, especially if our app in some way has to deal with shipping or mailing. It's really good to separate those things out. In this case, just for simplicity's sake, I'm going to keep it as just one field for the whole address, but just know that in many cases it would be wise in an address table to split everything out. So we'll call this ID and I'll just call this address, I guess. It's kind of weird that the address table would have an address field, but I can't think of a better name for it. All right. So we have a couple of misshapen tables with terrible handwriting on it. Let's talk about relationships. So we can think of within relational databases, if tables relate to each other, some tables don't relate to each other at all. If I had a table that had something for colors and then maybe next to that something for shapes, those tables don't relate to each other in any way. They're just two different things. But a lot of the times tables do relate. And when they relate, they can relate in one of three ways. The first way and the most common way is what's called a many-to-one or a one-to-many relationship. That's the most common relationship we are going to see. And this is it's as intuitive as the name sounds. It means that one entry in one table is going to relate to many entries in another table. So here's a challenge for you guys. Of these four tables, can you point to two of them that have a one-to-many relationship? That means one entry in one of these tables, let's say in table X, will correspond to multiple entries in table Y. So which two tables? Zoos to animals. So this is actually kind of a tricky question because there are different ways we could model this data. So which is good because that means that there's no one right answer. There are better and worse ways to do this, but there isn't one right way. So we could say that, so one way we could model it is we could say one zoo has many animals. That's totally valid. We could say that one zoo has many animals. We could also say that one species has many animals, right? So for example, the plot, well, in this entry, let's say the chameleon, that's one species, but there are two different animals that belong to that. We could also potentially relate zoos and species together, but be careful about that. So here's a question for you guys. Why would it not be fair to say that one zoo has many species? I mean, that's true, right, in a literal sense, that one zoo does have many species, but can anyone see why that's maybe not the full picture? Exactly, because the same is true in reverse. One species can have multiple zoos. So it's true that the San Diego Zoo has a platypus and a chameleon and a mole and so forth, but it's also true that a mole can be represented in multiple zoos. So that's where things start to get a little tricky. So I'm gonna, as I said, there are multiple ways to model this. But what I'm going to do is actually, let's set up this one-to-many relationship. So we said that one species can have many animals. So we have this one-to-many relationship happening here. So this is one, and over here is many. Once again, written poorly. So this is just objectively true. It's not possible for one specific live, tangible animal to somehow be multiple species. Even if it were a liger, it's not both a lion and a tiger, it's just a liger. So this does not go the opposite way. We are absolutely certain that for one species, there might only be one represented. Maybe it's a super rare animal that there's only one in captivity ever. Seems unlikely, but there's no way for this to go in reverse. We're assuming that for any species in this table, there could be many of them represented in the animals table. Okay, so in terms of foreign keys, how does this, so when we have a relationship, that means that there probably should be a foreign key in one of these tables. Should this table have a species ID or should this table have an animal ID? Which one? So we always want the foreign key to be in the many table. So I'll just do SID here because it's kind of short. Because we want to know which species each of our individual animals belongs to. Why would it not work to try to put, what would go wrong if we tried to put an animal ID inside of the species table? Can anyone articulate why it wouldn't work to put an animal ID inside of our species table? We'd have duplicate records. Exactly, so we'd need an entry, and then we're just back to where we started. We need an entry for Snuffles' ID, and we need an entry for Polonius's ID, all under star-nosed mole. So this brings up a question that I get a lot. I pretty inevitably get this at least once every time this comes up, which is, why can't we just have an array of animal? What if we had animal ID in here, and then we just had an array of all the IDs for the animals? Wouldn't that solve the problem? Well, yes and no. There's nothing per se wrong with modeling data this way. It's just, we've just defied the entire point of a relational database. Exactly, it's not the relational database model. So it turns out that document-based databases, something like Mongo, works exactly like this. So if you really want to do it this way, you could use a non-relational database, something like Mongo. But the short answer, I never like giving an answer that's just cause it's just that way. There's actually a very good reason that relational databases are designed the way they are. And let's go ahead and erase this because this is, that's way too big of an eraser. So relational databases are designed in this way very intentionally. It helps you access data from large stores of data in a very quick way. It helps you store things in a way that actually will make your life easier. So the whole point is that if you ever wanted to create an array, that would be a sign that you should put it in its own table and set up a foreign key. This animals table is almost like the relational version of an array. And yeah, as far as making actual awesome scalable apps and assuring that things are going to be modeled in a really meaningful way that won't create bugs and anomalies, it turns out that this whole separating concerns into different tables thing is actually a really solid idea. So I know it's frustrating because you're used to JavaScript where you can just throw stuff in an array, but you cannot do that in the relational database world. Okay, so that is the many-to-one relationship. That's the most common relationship that you're going to see. Let's talk about the many-to-many relationship. We already kind of touched on that. So with zoos and species, this would be an example of a many-to-many relationship. Now, if we wanted to avoid that, we could just link these tables. Honestly, this might be a better way to do it, but it's less fun and we don't get to see a nice little example. So we could say zoos contain animals and the species is just its own thing. But let's play with many-to-many instead. So another way we could think about it, and actually I will say this, this isn't necessarily the worst way to do it. It would just depend on what you were doing with this database. If you frequently needed to see which species were represented in a zoo, it might be better to do it this way. So the reason this is many-to-many is because in, say, the San Diego Zoo, we know we have many species represented, but for each species in here, we might find them in many zoos. So this would be many-to-many. All right. Here's a tricky question. Where do the foreign keys go? How are we going to set up our foreign keys on this many-to-many relationship? On a separate table, yes. And that's not just we prefer to, we have to create a separate table for this. We have to. And it's because of this array issue. If I tried to put a species ID on zoos, I would have the same issue of, but there are a bunch of species. If we tried to put a zoo ID over here, same problem. So we're actually going to have an entire separate table, a join table, that keeps track of which zoo goes with which species and so forth. So there's no room left on my whiteboard, so I won't whiteboard that out, but know that there will be a separate table that contains these two foreign keys. All right, our final, anyone want to guess what I might have already said this earlier, but what is the final relationship we're going to talk about? One-to-one, exactly. So this is one-to-one because we would certainly hope that there aren't multiple zoos at one address, and every zoo should only have one address. So the first thing I will say here is that in the case of a one-to-one relationship, generally speaking, you can combine them into one table without creating anomalies. So really the only reason to have a one-to-one relationship is if you have some sort of good reason. So one good reason in this case might be that if we are dealing with something like shipping, it might behoove us to just keep the addresses separate so that they're just clean and in one place, and when we're dealing with the shipping portion of things, we don't have to deal with accidentally bringing in any data from our zoo. So in this case, that is really the best reason I can think of having a separate address table, is if we were dealing somehow with shipping. If we were just wanted the address for reference, it probably would be better to just combine them into one. And as I also said, it would also be wise perhaps to split out street address, state, city, zip, so forth, but that'll just create extra work for us. So we will skip that step for now. Where do you think the foreign key should go in this one-to-one relationship? Both address. So there's not necessarily always a clear answer in one-to-one. You would not want to put it in both though. You'd really want to, it just would be extra and create an opportunity for an anomaly if somehow they accidentally mismatched. So I would not put it in both, but you could put it in either. In this case, I would choose to put a zoo ID here because you would maybe think of zoo as being the more, you could think of it as zoo is the main info and then address is kind of supplementary info on the side. So in a one-to-one relationship, generally one of the tables is going to feel like kind of the side fact, the place you go for some extra info. And usually you would want your foreign key over here. But if you put an address ID over here, if you did it in reverse, it wouldn't create a major issue. So whereas with this one-to-many thing, it's really important that it goes in the many one, you could get away either way. But like I said, I would not put both a zoo ID and an address ID because you would risk somehow having those not line up with each other, and that would be bad. You really want one source of truth for how these connect. So there should just be an ID in one field. Another fun fact is that you would generally want to make this ID unique. That will assure that that will once again assure that somehow you don't have two zoos listed, or the same zoo listed at two addresses. So God, that unique is almost illegible. I'm sorry. But you would want to make this unique to prevent anything weird from happening. You definitely would not want the species ID to be unique because the whole idea of many is that you would expect to see multiple copies of the same ID up here. Whereas because this is one-to-one, you would expect it to be unique. Just almost illegible, yes. If you know what it says in advance, you could probably read it. But if you're just jumping into the lecture, you're like, what is that squiggle nonsense over there? Maybe this whole thing would just look like squiggle nonsense. All right, so this is our squiggle nonsense diagram of how we want to model this data. We did leave out this join table business. We'll deal with that one on the fly. But does anyone have any questions about all of this before we jump in and actually start to create a code base to model, to write code with this? Get a tablet. Yeah, I have been wanting to, I don't know what the Wacom tablet is specifically, but if it's one of the ones that you actually write on, I just kind of want to get one of those anyways. So I can write it off my taxes if I buy it. So maybe I'll just get one and save the future generations of Lambda students the pain of what just happened up here. All right. Well, I think now is probably, it's a little early, but let's go ahead and take our break now, since we'll be switching gears to doing some coding afterwards. So let's take a 5-minute break, and then when we get back, we'll be creating a code base from scratch and working with some of this stuff. All right, I'll see you guys in 5. All right, welcome back. So one slight positive alteration I want to make on our schema diagram here before we jump into the code is we talked about how zoos and animals are also this one-to-many relationship. That says many. So what's nice about thinking about it this way and even putting in I'm running out of room here, but a zoo ID up here is that we could actually, even though these are many to many, we could actually think of this as being the join table that connects them together. So if we just connect these in this way, we'll actually solve this many to many problem and we won't even have to pull in an extra table. Plus, we'll be keeping much better track of where our animals are actually living. So that's good. So that's how we'll design our schema, is we'll just have these 4 tables and we'll put a zoo ID on animals. But before we can start to write some schema code in Connects, we need a code base. So for this next code base portion, I would encourage everyone to actually code along with me while we're just setting up. Once we get into the actual code, I'll give you time to catch up. So we've mostly been having you work with stubs of files, but we're going to start everything from scratch today because that's a skill you guys should all have. So if you have any questions about this process, you get stuck on something as I go along, please reach out. So first I'm going to make a directory. I'm in my Lambda projects folder, so that's a good place for it. I'll call this zoo animals db4. You can call it whatever you want. So right now this is just an empty directory. I'm going to go ahead and open it up in VS Code. All right. So completely empty. I'll open my terminal in here. Now the first thing I want to do is get init. Oh, that. And then let's do yarn init, and I'll do -y. And -y just kind of auto answers yes to all the questions. Where is my, okay. So I have a package.json. The other thing that I want to do is I'm just going to go ahead and create a get ignore. I don't think there's really anything except node modules that we actually want to ignore, but always good to have a get ignore. So I will do, oops, sorry, 1 second. All right, I've created my get ignore. And I'll go ahead and save my node modules in here. It's not quite as fancy and nice as the big old get ignore we usually work with, but it's a starting point and it'll do for our purposes. The other thing I want to do here is I just want to go ahead and set up, I know I'm going to want a server script, so I'm going to create my scripts in here. And there's no node on yet, but I know it's coming. All right, any questions, or I'll give you guys a second to catch up. Any questions on what I've done so far? Get ignore. Sure. I think we have to try. I'm not used to creating a get ignore from scratch. I'm trying to remember if we need the slash or not. You probably have to just double check the homework. Yep, looks like we do want the slash. All right, the next thing I want to do is add some dependencies. What dependencies do you guys think we'll probably just need, just based on everything we've been doing so far in the back end? What do we want in here? Express, definitely. Connects, SQLite 3. We might not even get to Express, honestly, but we're going to want it at some point. So, oops, I forgot my add. There we go. And then someone mentioned Notamon. Absolutely. I will add that in a moment as a dev dependency once all these are done. Okay. And unless we wanted to put some middleware in, which I'm not going to bother, I think that should do us. Last thing I want to do is set up my, or well, several more things to do. I'm going to create my index.js. I'm going to go ahead and create a data directory where all our database stuff will live. Or, sorry, not touch. All right, I'll give you guys a second to catch up. Any questions on anything I've just done? So the last bit of setup I want to do is connects specific. So whenever we're using connects, what extra setup step do we have to do? Connects and init, absolutely. Remember, if for some reason you don't have connects installed globally, you can always do npx connects init, and that'll work too. And what we will do in here is we will get rid of this staging and production environment stuff. Don't care. I've done this a million times. Well, let's name this zoo animals. And we want this to be in data. Remember, we always want this use null as default when we're using SQLite. And then I'm also going to specify the directory for my migrations and seeds so that they will live inside of this data folder. And down here, what have I done? Okay, there we go. All right, that is set up. I'll give you guys a second to catch up. And I don't want to just copy this over for you guys because I want you to practice writing it out so you can soon do it in your sleep like I can. Even though I still misplace parentheses and apostrophes and things like that. I'm going to actually, I really don't want us to move on until you guys are all caught up. So let me throw a poll in here to make sure. So if you are not, I'm about to submit this. If you're not ready, please check no. Brett, is there anything we can do to catch you up, or are you a lost cause? I'm sure you are not a lost cause, but is there anything we can do to catch you up? Oh wait, I meant to make this anonymous. I'm sorry. I thought I clicked it. All right. Well, I apologize for not making it anonymous. I know that makes things awkward. Okay, hopefully you guys are pretty much ready to go. So our next step is we came up with this super cool schema. Now we need to actually write this out in our connects migrations. So order matters here, right? Because of foreign keys. So can anyone, there are multiple ways we could do this. There's not just one order, but there are right orders and wrong orders. So let's start here. Sorry, I'm babbling. What do you think is the first table we should make? What is the first table that we should make? Zoos. Good way to go. One, because conceptually it's kind of just at the start of things. Two, it has no foreign keys. The big rule here is we can't create a foreign key until that table exists. All right, so what's potentially the next table we might want to make? We heard addresses or animals. This one's tricky. This one's kind of tricky. We could make addresses or we could make species. Animals is actually the only table we can't make next. So here's a question for you guys, and it's not totally obvious, but why can't we make the animals table second? Because of the species ID. We cannot make this table until we've made this one. So these are our next two options. I'm just going to say let's make addresses second, but it would be totally valid to make species next. Then we know we have to make species, and then we will make our animals table fourth. So let's start with zoos. Zoos is going to be pretty straightforward. So we'll do connects, migrate, make, and I'll call this create zoos table. And we see it's been created. That's always a good sign. So let's jump in here. Now we're using this connects.schema object whenever we're designing schemas. And there's this nice create table function in here. It'll take in a table name and a callback function with this table object that will allow us to actually design the schema. All right, so we have zoos. And this schema was really simple. It just has an ID and a name. So in connects, the ID, the primary key, we just use this increments function. And then we'll do table dot, is it dot string? Yeah. And I'm actually going to call this, instead of name, I'm going to call this zoo name. It turns out that while we could say name, but I'm going to call these, give these unique names, and it will make life a lot easier when we're joining. So I would recommend creating unique names for columns. You don't have to, but it'll make life easier when you get to join statements. So constraint-wise, I think it's safe to say that this should be required, so we can use not nullable. And it should probably be unique. Well, I don't know. Maybe there are zoos with the same, it's possible that there's zoos with the same name, but let's not make it unique. You never know. Hopefully we don't have duplicate copies in here, but it's possible that we would have different zoos with the same name. So let's just make it required. All right, who can tell me what goes in the down function? So on a more conceptual level, the down function is where we undo whatever we did in the up function. So if we're creating a table, we know we want to do connect schema, drop table if exists, and then we pass in the name of the table. All right, I'll give you guys a second to get caught up on this. Okay, let's create our next table. So connect, migrate, make, create addresses table. So very similar. We're going to do connect schema dot create table. This one is addresses. We will have, of course, table.increments followed by table.string for address. Maybe just to, I don't know, we'll just call it address. It's bothering me that the field and the table name are so similar, but oh well. This we want to be not nullable. And I would say we definitely want this to be unique. There's no reason that there should be multiple addresses in this table. Whereas potentially there could be multiple zoos with the same literal name. There's no way that we would have unique or identical street addresses in here unless it was literally duplicate data. Keeps making a separate directory out of. What do you mean it keeps making a separate directory? Like, can you show us maybe a screenshot of what your file structure looks like? It's making one outside of it. I think that something must be slightly, there might be a typo, like does this say migrations or does it accident, or if that's tucked somewhere else, or if this says file name instead of directory. I would maybe copy over your connects file because my guess is there's just something slightly off kilter in it. Okay, I'm assuming that thumbs up means it was whatever was happening is worked out. All right, so the next thing we need in here is a foreign key, which as you probably remember is a little bit wordy, but not too bad. So we'll do table.integer. We will call this zoo ID. And we remember we want this to be unique because it's a one-to-one relationship. If this were a one-to-many, we normally don't want foreign keys to be unique, only in the one-to-one relationship. Otherwise, you'll get in trouble. And then we want unsigned. That's just saying can't be negative. We want, let me just put this all down here. We want references ID in table zoos. And then we want this cascading stuff. This is just saying that If I ever delete my zoo, the address will be deleted along with it. This is another reason why it's important to think about where the foreign key goes on this one-to-one relationship. If our database were more oriented towards addresses, we would really want deleting a zoo to still preserve the address. So in this case, if we delete the address, the zoo stays. But if we delete the zoo, the address will disappear. So kind of another interesting thing to think about when you're designing things so that you make the right choice for your project. You could also not include this, which would say, if you try to delete the zoo, it will yell at you because the address still exists. So up to you. It really just depends on the needs of your project. All right, and then let's create there we go. I want you guys to have these two migrations in place before we move on. So I'm actually going to make it anonymous this time. I'm going to put another poll up so I know when everyone's created these two migrations. All right. Did I miss table? Oh, drop table if exists. Thank you. So here's a question for you guys. Do these tables actually exist in a database yet? Let me split my screen so you can see both of these. No, they don't. So we've written out the logic for creating them when we're ready, but these have not been created yet. And we would have to actually migrate latest. So let's go ahead and run that. We'll find out if I have any other typos in here. Uh-oh. There is a typo in here. Good thing we ran this. What did I do? Oh, I always do this. References, plural. Unsigned means that this cannot be negative. It's required in some database management systems, so I don't think it matters in SQLite, but it's a good habit to get into because you want this schema code to work regardless of what database management system you're using. All right, there we go. So it looks like a couple people are still catching up. We'll wait a little longer, but once you're ready, make sure you change your vote so that we know when it's time to move on. And let me know if anyone has any questions I can help you out with in the meantime. My error was I had accidentally written reference instead of references. So when I scrolled up to the top of this big red pile of doom, it says blank dot, blank dot, blank dot, reference is not a function. So that told me that this was the issue. All right, almost everyone is there. I'm going to go ahead and move along because I want to make sure we get to everything. So the next things we have to do are create, where is my whiteboard? Goodness. Where did you go? No, it's in here. There it is. We want to create species and then animals. I want you guys to do that. So I'm going to give you about, let's say 5 minutes. I know that's not that long, but 5 minutes to try to create these two tables. One thing I want to say is make sure that this is, don't name these both name. Call this species name and animal's name. And this animal should have 2 foreign keys. So I can even, if you want, I can just type out what I want to see in those. Because I know my, I'll just put a comment down here because I know my handwriting is terrible on that whiteboard. So species should have ID and species name. And then animals should have ID, animal name, zoo ID, species ID. That's what I want to see. So let's give you guys 6 minutes to create those 2 migrations. And remember to try and run them too, because then you'll find out if you have any typos or not. So let's just kill this thing. All right, and go. So you'll have to create a migration for 2 new tables, a species table and an animals table. All right. Let's go ahead and create these tables. So the species one has to come first. Let's actually bring that back real quick. Species one has to come first because the animals one is going to reference it. So order does matter here. So I'll start with connects, migrate, make, create species table. I'll just go ahead and run the next migration. Or generate the next migration, create animals table. Okay. Species. Just close this one. So we can do return very similar to what we've seen already. Create table, species. We always want increments. Oops. Table.string. And I am using unique because there really should be a unique entry for every species in here. It's not really possible that, like with the name of an animal, you know, you could have to bury the bobcats at different zoos that are two literal different animals. But the species name, if there's duplicates, it's probably because of an anomaly. There shouldn't be duplicates. So that's why we'll make species name unique. And then down here, we'll do drop table if exists species. All right. So that one was pretty straightforward, very similar to zoos. And then the last one we have is our animals table. This one's the trickiest because there are two foreign keys in here. So I'll do return connects.schema, create table. Table.increments for our primary key. We'll do table string animal name. This one will be not nullable, but it will not be unique because they're almost, if we have a giant database full of animals, there almost certainly will be animals that have the same name but are actually different animals. All right, then we'll do table dot, here are two foreign keys. So we'll do table dot integer. We do not want unique because this is a one-to-many relationship. Unsigned, we want references, plural, ID. And wait a minute, I forgot the name of this. Let's start with zoo ID. ID in table zoos. On delete, cascade. On update, cascade. All right. And then I'm just going to do a little copy and paste magic here because our second foreign key, which is our species ID, will look almost the same. Just have to make sure that we change this reference and that we spell species. Species. I think I spelled it correct. Should update be? No, it shouldn't. Thanks, guys. All right. And of course, well, let's find out if I have any typos in here. Looks good. Let me give you guys a second to especially catch up on this one. There's a lot going on in this one. Any questions on this schema design, whether it's questions about how I'm using the connects language or about the design itself? And notice that this is a subtle thing, but this animals table is actually a join table. Because it contains two foreign keys, it's actually, in a way, joining these together in a many-to-many relationship. And even though the animals table kind of has its own purpose, it's possible sometimes we'll see a table that just has two foreign, it just has its own ID and two foreign IDs. That's a pretty common thing. And whenever you have a many-many relationship, what you'll find is that there's another table that just has its own ID and then these two foreign keys linking these tables together. This one happens to also have an animal name because it kind of has an additional purpose beyond just joining them together. It's also keeping track of the names of the animals. So in the case of a many-to-many, you always need a join table, but keep in mind it's a separate table. So I think, did I kill my beautiful diagram? I think I did. But because species and zoos had a many-to-many relationship, the only way to link those together would have to be in a third table. All right, let's create some seed data for this. So I'm going to just go ahead and create all my seed files. Remember, we like to order these, but we have to actually write in the numbers with our seeds. So we'll do the same order. We'll start with zoos. Addresses. Species. And finally, animals. All right, so coming up with seed data is no trivial task. So I actually, hold on, let me fix. I came up with some data for you, but I just realized that I need to fix something on it. So give me a second to do some stuff off screen. Okay. All right, I am about to paste some seed data into Slack. So you can go ahead and use this to follow along with me so that you're not, that would be absolutely horrible to try and type this out. All right, so let's close our migrations and go into seeds. Start in zoo, we want to change this to zoos, this to truncate, and I will copy my zoo info into here. All right. I'm just going to kind of work on this at my own speed, let you guys catch up. This should be pretty mechanical. Creating seeds is not hard. I mean, it shouldn't be hard, but it ends up becoming hard because it's tedious and you have to keep track of things, and you guys will have some fun with that tonight in the homework the next couple days. Let's go into species. I don't expect you to, I'll give you time to catch up. I don't expect you to be quite as quick as me. We'll pass that in. And then finally, All right. I'm going to throw up another poll so you guys can let me know when you're all caught up. And it'd be worth actually running the seeds when you're done. I should probably do this to make sure everything works. So connects, seed, run. Looks like it worked. I did zoos, addresses, species, animals, which is the same order we did for our migrations. As with the migrations, there's other orders that would work. You just have to make sure that foreign keys come after whatever table they rely on. All right, right now I am seeing that only one person is not finished. If people are still working on this, please vote no. Otherwise, I will be moving on shortly. Oh, there we go. And the number jumped up. All right, I will give you guys more time. And anything I can do, any questions? Is the Minotaur's name Steven? I think so. Let's check. Minotaur is number 1, 2, 3, 4, 5, 6, 7. Yep, Steven is the Minotaur. I had a lot of fun coming up with these. I feel like I've done my job correctly when the database class just devolves into Minotaur puns. One might even say that I'm amazed at all the Minotaur puns you're coming up with. All right, I'm going to give you guys a few more minutes. This is devolving quickly. So I'll give you guys a few more minutes to catch up on these seeds, but we're going to have to move on shortly. All right, I think it's time to move along. So in the last few homework assignments, you have been writing connects code. I've got a lot of stuff open. You guys have been writing connects code directly into your index.js, which is fine. It works, but it's not ideal. So we actually don't like to see connects code directly in inside of our endpoints. So we're going to be writing things from scratch this time, but can you guys remember from the first sprint, where did that connects code actually go? Where was it hiding? How did we separate, speaking of separation of concerns, how did we separate out our actual route handlers from our connects logic? We just had a separate file full of database helpers. Exactly. And there are lots of ways to do this. You could have separate files for separate resources. We could have a helper file for zoos, a helper file for addresses, a helper file for species. We're not going to bother. We're just going to do one database helper file where we'll put everything. We're not going to write full CRUD helpers for all of these tables because that would take the rest of the night, but we'll do a few. So I'm going to go ahead and create inside of data a file called dbhelpers.js. So in this thing, we definitely want to export whatever we're planning on using. So I'll just set this equal to an object and go ahead and put some helpers in here. So just to get us off the ground, we might have something like find species. And this thing, since it's getting all of them, will just be a function. We might have a, find zoos. Generally, you would want to actually separate out the resources, but you guys get the picture. Find zoos, and then let's do one called find animals. Now, these are all get helpers, but of course, we'd also have inserts and deletes and this and that. But we'll start with these guys. And then over here, our index.js is pretty pitiful right now. We probably won't even bother with our server. But we know that we would have some sort of DB object here where we required so that within our endpoints, we could use these guys. I'll go ahead and, you know what, let's just start this out. Why not? So actually, I'm sorry, I keep changing my mind. We're just going to leave it alone. You guys know how to create an Express server. That would also be in here in a room. Pretend there's an Express server in here. Okay, perfect. So let's focus on these guys. We definitely need connects in here. So we'll go ahead and require connects. And then we want to where does our DB config object come from? Because in order to instantiate connects, we'll have to plug in our config object. Where does this come from? This is our config options, the connects file, exactly. And then we can do db equals connects, and we pass in dbconfig.development. In the real world, this environment could change dynamically, but for our purposes, we can hard code in development, and it will pass into this connects function this config object that it will tell us all the important stuff. All right, so now we're ready to do some logic. So we can just do the basic connects logic we've been working with. Something like return db.species, return db.zoos, and let's do return db, not db dot, db pass in animals. Okay. As you guys catch up with all of this, well, I'll give you a minute to catch up, but another fun question to think about, how do we test? How do we test and make sure that these three functions I just wrote actually work? This is an important question because you'll be doing something similar on the homework tonight. And as fun as it is to write code blinds, how are we going to make sure that all three of these, or really any of these, do what we hope and think they do? We could use Postman after we write the routes. That's the best way to go. But immediately after writing them, we'd like a way to just know. So maybe there's a shortcut. Absolutely. We could. So the proper answer would be to write unit tests, which you will learn how to do in 2 sprints. But since you don't know how to do that yet, we can just kind of hack it out. So we can do db dot find zoos dot then at this point, it might just be worth it to write the endpoints, but you can do it this way. So let's try it out. Oops. I thought I created a server script. What's going on in my package.json? Oh, another typo. Let me split this so you can see what's going on in DB helpers. So we want a server in here, but we can put whatever in here. We can just tinker around and see what we're working with. Not a bad way to go to start. We see we're getting back both of our zoos. Let's go ahead and do this for our species. You don't have, by the way, you do not have to put all this on your code base if you don't want. But I want you to see how I'm doing this so you don't feel blind when you're working on your homework tonight / tomorrow. Cool. So we see we're getting a list of animals, a list of zoo, a list of species. All good signs. Awesome. I think that it's kind of hard to screw up a basic select and connects, but everything seems to be working. All right. So let's up the ante. I'm going to comment these out right now. I just care about zoos for right now. So this zoo business is fine and all, but honestly, I would really like to see the address of the zoos. In order to, oh yeah, before I go on, how do we start the server? So inside of my package.json, I set up this script. I can just copy this over for you. That says on server run nodamon index.js. So you could always just run, if you wanted to, you could just always run the command node index.js, and that'll just run the server file. But we don't like that because it doesn't keep track of if we make changes. So that's why we always like to set up a script that runs it with nodamon, because then every time we update it, it'll restart. All right. So it's nice that we're getting the name of our zoo, but I want to see the address too. So how are we going to fix that? How could we potentially change this find zoos function so that it also displayed the address? What little trick that we maybe haven't seen in Connects yet, but we explored on Monday might help us out with this conundrum? Joining, yes, joining. That's where all this was leading to. So could I please show index.js? Sure. So I've just run, very similar to how we use these methods inside of our endpoints. I've just run db.findZoos, but then I've just done console logs in the then and the catch. You could also, you wouldn't even really need the catch. I mean, it's kind of nicer if you do the catch, but if you don't do the catch, you'll still see the error if it throws one because your server will crash. But yeah, so we want a join, which we know how to do a join in SQL. It would be something like select all from zoos, join addresses on zoo ID equals zoos.id. So that's how we do it in a SQL world, but we're in Connects world now. So let's check the docs. It's pretty easy actually, but let's just go to the docs. There's a whole join section, a whole nice join section, all these different joins, including join raw, where you can write raw SQL. But I think a good old-fashioned inner join is going to do us just fine here. So what we can do is there are a few different ways to, as is often the case with Connects, there are a handful of different syntaxes that we can use. I think this one's just fine. So we'll do Connects from one, inner join the other one, and then the two fields that should match. Remember, DB, that's the same thing as Connects on the docs. I don't even know. We might not even need from. Let me try something. So what? Let me double check. I think inner capital join. Dot inner join. So we want to join on the addresses table, and then we can just pass in the two fields we want. So zoo ID and zoos.id. Let's try it out. Oh, it worked. So now we see the zoo ID and the address. Any questions on how I did that join statement with Connects? I don't need any selects. I'm saying select all. So if I wanted to, if let's say I didn't want the zoo ID, I'm like, I don't care about the zoo ID. I could db.select, and I could do zoos.id, zoo name, wait, hold on, dot from, this is getting ugly. So zoos.id, and then let's say I want zoo name and address. I think this will work. Let's try it out. Yep. So if I do want to select specific fields, I can do db.select and then a from inner join. Otherwise, it will default to selecting everything. I couldn't just say ID because zoos and addresses has an ID field. So it might give me the wrong one. I mean, let's just see what happens. Yep, so it says, and it throws an error, ambiguous column name. It doesn't know which one. So that's why I wanted us to specify zoo name, species name, animal name. That's why I did not want us to call all those fields name, because once you start joining them together, it creates a lot of extra work because you have to be really, really clear about which fields you're talking about. All right, any other questions on this stuff? Okay, I know we're getting to the end, but I have one final task for you guys. I want this animals endpoint to include the species name. I would like to see, not just see the animal name, but I would like to see the species name as well. So I'll give you guys, should be pretty easy. It's pretty similar to what we just did. I'll just give you guys 3 minutes to work on that one. All right, so what I want to see is I'll scroll up. All right. So to start, I'm going to go over here and comment in my find animals so that I can just see what's going on. So we see right now we've got the animal names, but some other ugly stuff that we don't really care about. So I'm going to change this to db.select. I want to see the ID. I'd like to see the animal name. And I'm going to want to see the species name too. We're going to start with from animals. And then I will do an inner join. We'll join on the species table on species ID, which of course comes from the animals table. And then we'll do species .id. So this is the foreign key coming from our animals table. This is the primary key coming from our species table. And as with up here, we do have to specify which table each ID is coming from, or else we'll get that ambiguous error. So let's save it. And we see that we're now getting ID, animal name, and species name. Does it matter which order we put it in? Depends on what you're talking about. Up here, the order of the select matters in terms of it's the order that it'll be displayed in. That's what that is. Out of these two, the order does not matter at all. This could be reversed and it would behave exactly the same. It also doesn't matter. We could swap these and it would be the same because we're working with an inner join. An inner join, it doesn't matter what you're joining on what necessarily, as long as it's just a single join. Speaking of a single join, if we wanted to take this a step further, we could add a second inner join. And we could join on zoos. See, in this one, I've reversed it. I've done zoos.id first and then zooid second. So it doesn't look any different because I haven't changed the select yet, but let's add zoo name on here. So now we see the animal, its species, and what zoo it lives in all in one go. We could take it even further and attach an address on here, but that gets tricky because we cannot join an address onto animals because there's no address ID. So we'd have to, there's a few different slightly convoluted ways to do this, but it wouldn't be as simple as just throwing another join on if we wanted address in here as well. All right, questions on this stuff before I go over the homework? All right. So homework, this homework is tricky. So I'm gonna give you guys some hints that will make it easier. So listen up. I'll give you some tips that will make this homework a little easier. It's tricky not because the code is difficult, but because it requires thinking and database design, and it's very open-ended. And you can make your life really hard if the database design is weird. So my advice to you is just like we did tonight, we spent like almost 50% of the lecture just doing crappy whiteboarding. That matters, that's important. If you jump in and start coding on this homework, it will probably take you more time. Sit down with a pen and paper or whatever you prefer and really think about what you want your schema to look like. Take some time to do that. Do not neglect that. Don't feel like you have to rush through that to get to the real work. That is the hardest part of this assignment and the most important part. One other tip that might make life easier is write your seed files before you write your schema. Now, you can't run your seeds until you've run your migrations, but try just writing the seed files, just kind of like what I pasted into Slack, just writing out JavaScript objects. If there's something wacky in your schema design, you'll probably figure it out pretty quickly when you write your seeds. So once again, you might save some time by trying to write your seeds first. So those are my 2 little hints on how to make this easier. So your job is to model this kind of recipe thing. So the resources are bolded. This is a hint. These might refer to tables. These are client requirements, which means this is tricky. This means that you have to be thinking about, as you design your schema, that eventually you might want to be able to do this. For example, let's look at this last requirement. So we have these dishes and these recipes, and theoretically we want to be able to get a shopping list for a recipe that lists all the ingredients and the quantities of each. So that doesn't mean you need some shopping list table per se, but it means that you should design these tables in a way where you could eventually functionally get a shopping list. So this is tricky. It's requiring you to take kind of these surface level client requirements and then think about what database would serve them. Once again, do not rush through the step of designing this database. That is the hardest and most important part of this assignment. So once you're finished with that, you want to create seeds and migrations. And then we'll want to do, just like we did here, a data access file or a helper file with these 5 helper functions. So notice that creating a server and endpoints is not at all part of the MVP on this. So you can't, if you just want to go ahead and do those, you're welcome to. But while you're tinkering with this, it might help you to just kind of do some console logging like I did here so you can see what's going on. Of course, there's lots of fun stretch problems. The first being write the endpoints to map to this, and then you can create even more crazy methods. And this really, if you want a challenge, I would do all of these stretch problems. There's a lot here, but just focus on this. And remember that designing the schema is the fundamental part of this assignment. And that doesn't even need to happen on the computer. You can sit down with a pen and paper in the park. I don't know about where you guys live, but it's been really beautiful here in Southern Arizona the last week. So go to a park and design your schema, get some sunshine. Us programmers don't get enough of it. All right. Well, that's the assignment. I'll post this in Slack so it's easily accessible. Final questions on that, on anything we talked about tonight? Yeah, we've got to get our vitamin D. It's the only way we get vitamin D is designing database schemas in the park periodically. All right, I think people have spoken. It's time to end the lecture. All right, good luck with it. Good luck with this homework assignment. Don't underestimate it. This type of database design stuff is tricky, but it's important skill. All right, I will see you guys on Tuesday when we will start the authentication sprint. Good luck with this. As always, I'll be intermittently around in Slack and ask for help, talk to each other, all that fun stuff. Oh yes, I've done a terrible job of sending you the repos. So I do like to hold off. I'll send you the repo for Monday, but I'm going to wait a couple days to send you this one so that you guys aren't taking the shortcut. I know, I'm mean, but all right. Have a good night, you guys.